Alright, so here we are with Chapter 4, Cluster 2. It's called Working with Exponents, and there will be 2 class activities. So for our first class activity, we're going to take a look at the rules of exponents. Okay? But first off, what is an exponent? Alright, so just a little reminder here. If we have 2x squared, or maybe 5x squared y cubed, what are the exponents? Well, for this term, the exponent is that 2. So we would call this x squared. For this term, the exponent on the x is 2, but we have another exponent on the y, which is 3. Okay, so the exponent is the power our variable or our number is being raised to. So let's take a look at the rules of exponents. These are the things we want to know because then we can use them to work with exponents. And there are 8 of them. Alright, so the first one. If we have a base, b, raised to the m power, and we times it by another base, b, to the n power, what is this going to be? That is going to equal, so what we say is keep the base and add the exponents. So add the exponents. And this is if the base is the exact same base. So that's the first rule. The second one. If we have b to the m, and this time divided by the same base b to the n power, what that is going to be is b to the m, and this time it's going to be you subtract the exponents. And this is important. You subtract the bottom one from the top one. We cannot switch this around. Remember, subtraction, it's not commutative. You cannot switch it around. So it's always the top number, the top exponent, and you're going to subtract away the bottom exponent. All right, so multiplication would be addition. Division would be subtraction. Okay, so let's take a look at the third rule of exponent. So for the third rule, we're going to bring in some parentheses here. A times b to the n power. A times b to the n power. So what is this going to be? Well, what we're going to do is, when we see that a multiplication sign here, remember this is not an addition sign, that's a multiplication. If we have multiplication, then each of the, I guess you could say, each of the numbers or variables inside the parentheses, no matter how many, you're going to raise each of them to the power on the outside. So this would be a to the n, b to the n, multiplication. Okay, let's take a look at the fourth rule of exponents. So for the fourth rule, we have a over b to the n. So this time, instead of the multiplication, we're looking at division on the inside of our parentheses. But sort of the same idea happens. Whoever is on the inside will be raised to the power on the outside. So this will be a to the n, still divided by b to the n. So each of them got the power to the n. Almost halfway through. All right, so number 5. Number 5. Another parentheses problem. This one, it's called the power rule. All right, so it can look rather similar to this rule, but it's different because notice we have 2 exponents going on here. So when we have the 2 exponents, what happens is we keep the base and the exponents end up multiplying to each other. Okay, so this rule is different from the first one. In the first one, we add the exponents. But for this one, because it's one power being raised to another power, you're going to end up multiplying the exponents together. And we will look at examples of these, so don't worry. All right, number 6. B to the 0 power. This one's interesting. Any number raised to the 0 power is going to always be 1. No matter what the base is, if you raise it to the 0 power, your answer will be 1. Alrighty, and number 7. B to the 1 power. Well, anything raised to the first power is just going to be itself. So b to the first power is b. And the last one that we're going to take a look at, b to the negative exponent. This one I like to call fish out of water. I'll show you my reason. So if we have a fish out of water, let's say you're a fisher and you have a fish out of the water. Okay? That's supposed to be a fish. Is the fish happy? No, it's a negative fish. Okay? The fish is feeling negative. He's out of the water. So how do you make a fish happy? Well, you'd put him back in the water, right? So if you think of the fraction line as being the water line, put the fish under the water, and now the fish is happy. It's a positive exponent. Okay? Sort of a funny example, but I find it helps me. Okay, so when we see a negative exponent, we think fish out of water. To make the fish happy, we're going to put it under the water line. Remember, that's a 1. And now my fish is happy. It's a positive exponent. All right, so those are the rules of exponents. We'll do a few examples with them for class activity number 1, and then we'll move on to class activity number 2. Okay, so that was number 2, so let's look at number 3. Use the rules of exponents to simplify. So 2 to the 3rd power times 2 to the 1 power. Let's see, what scenario does this match? Which one of the rules could I use this with? I'm looking with same base and multiplication between them. Let's see. Not this one. Those are 2 different bases. I'm looking for multiplication. Ah, right here, number 1. I got the multiplication and then the same base. So what was I supposed to do? Well, I keep the base. So we're going to keep the 2. And then we're going to add the exponents, which means I'm going to take 3 and add it to 1. So that's going to equal 2 to the 4th power. Let's take a look at another example. 4. 4x squared. All right, take a look at our rules of exponents. Can you find the one we would use to simplify this? Number 3. We'll go ahead and use number 3 because the bases are different. They're being multiplied and they're in parentheses raised to a power. So the same thing is happening here. So this is going to be 4 to the 2nd power times x to the 2nd power. Simplifying that, 4 squared is going to be 16x squared. Alrighty, number 5. 4 to the negative 3rd power. Let's simplify this. Do any of these rules have a negative in them? Let's see. Number 8. It's our fish out of water. Okay, so how do we solve this? How do we make a fish happy? Well, we're going to put it under the water. Put it to the 3rd power. So what is 4 to the 3rd power? Well, if you don't know that or have it memorized, I believe it's 64. You can go ahead and use your calculator. So do 4 times 4 times 4, which is, 64. 1 over 64. 3 more to go. So let's see. Number 6. 3 to the 5th power divided by 3 to the negative 4th power. So what kind of a problem is this? Well, it's division with the same base. Do I have division with the same base in any of these? Number 2. Number 2 is division of the same base. So what do? Well, we keep the base and we subtract the exponents. So we keep the base, and remember, we keep the top exponent first, and we're going to subtract the, oh, interesting, that's a negative 4. So I'll be careful, and I'll use parentheses, and I'll subtract the negative 4. So this is going to be 3. 5 minus negative 4, ooh, a double negative. That means 5 plus 4. So that's going to be 3 to the 9th power. Kind of tricky, Alrighty, let's see. That was number. Okay, so let's see. Number 7. 2 to the x divided by n to the third power. All right, so we've got division going on. The bases are not the same, and it's being raised to a power. Do I have a rule for that? Division, division. Okay, these two are the division, but I'm looking for one that has different bases. So we're going to go with number 4. So what do? Well, they each get the exponent. All right, so this is going to equal 2 to the third power times x to the third power. Remember, each of the bases get the exponent, n to the third power. Can I simplify this? Well, I can do 2 to the third power. That's 2 times 2 times 2, which is 6. Very good. Oh, not 6, 8. Huh. Don't know where that came from. All right. And last but not least, number 8. Ooh, this one's fun. 4 to the 1 power plus 4 to the 0 power. Well, let's see. Where's anything raised to the 1 power? Right there. Oh, it's just going to be itself. Okay, well, 4 to the 1 power. It's just going to be 4. Plus 4 to the 0. Where's that 0 rule? Right there. That is just going to equal 1. So, what's 4 plus 1? The answer is going to be 5. All right, and that's it for this class activity. Let's take a look at the other class activity for rules of exponents. Okay, so class activity number 2. Okay, so using rules of exponents. Alrighty, number 1. Write in exponential form. We have 2 parts. A. So how would I write that in exponential form? I have m times m times m times m times m. Well, when you're multiplying, you keep the base and add the exponents. So what are the exponents on these m's? Well, they're all 1s. So keeping the base, m, and adding the exponents, I have 1, 2, 3, 4, 5. Well, does that make sense? Am I multiplying m 5 times? 1, 2, 3, 4, 5, yeah. I'm multiplying m 5 times. All right, and B, same directions. Go ahead and try this one by yourself. Alrighty, let's see. Okay, interesting. These bases are not all the same, but we do have multiples of the same base. So we have x, how many times? 1, 2, 3. It's x to the third power. And then we have y to the 1 to second power. So x to the 3 times y squared. All right, that was it for number 1. Number 2, simplify. X cubed times x to the 7th times x. What would that equal? Well, let's see. So we have the same base, x, and x, and it's being multiplied together. So the rule for that is you keep the base and you add up all the exponents. So what are the exponents I have? I have a 3. So I'm going to add that to a 7. And then, what's the exponent on x? Remember, that's the 1. So plus 1. That's going to equal x to the, so 7 and 3 is 10, and 1 is going to be x to the 11th power. That is the simplified form of this. All right, and we have 1, 2, 3, 4, 5, 6, 7, 8 more problems to go. Oh, I don't know why I wrote 8. Number 3. Okay, so same directions. We're going to go with simplifying. Using rules of exponents. X to the 6th over x to the 4th. Okay, go ahead and look at your rules of exponents that we had. I can bring them out actually. So what rule of exponents would we use for this problem? Which one does this look like? So it's the same base being divided. Number 2. It looks like number 2. So what's my plan? Subtracting the exponents. So this is going to be x to the 6. Remember, the top one is always on top. Minus 4. That's going to equal x to the second power. All right, let's look at the next one. Number 4. m to the 4th times 3. Okay, bringing out our rules of exponents. Remember, these should be memorized, but we just learned them, so we can bring them out. Let's see. We have parentheses being raised to a power with only one thing inside. Looks like number 5. So what am I going to do? Multiply the exponents. That's going to be m to the 4th power times 3, which will be m to the 12th power. Next problem. Number 5. h to the negative 3. You should remember this one. It's the fish out of water. So what's our plan? Put it underwater and make the exponent negative. So the whole plan for this one is basically you're trying to get rid of a negative exponent. And by doing that, you create it into you put it into a fraction. And there we go. Number 6. t to the 0 power to the 3rd power. Which one does this look like? Oh, it looks an awful lot like that. So you can use that same rule. So it's going to be t and then 0 times 3, which is going to equal t to the 0. Well, what is anything to the 0 power? 1. Yeah. You can see that on our rules of exponents right there. Anything to the 0 power is 1. All right, number 7. So let's see. So 2 times 5w squared to the 3rd power. Ooh, this one's getting more interesting. So now we're going to get to the point where we're going to start using more than one rule of exponent in a problem. So this one, let's see, what's happening here? We have 2 being multiplied to numbers inside parentheses being raised to a power. So I can't multiply the 2 in yet because of that 3 on the outside. These guys are being held captive by the 3. So we need to get rid of that 3 first. So the rule of exponent I'm going to use will be number 3. So this is going to equal 2 times 5 to the 3rd power times w squared to the 3rd power. Now, are there any other rules of exponents I can use? See those parentheses? This one is rule 5. So we'll multiply the exponents together. 2 times 3. So 2 times 3 is 6. And simplifying, I have 2 times 5 cubed is, 5 times 5 is 25, and 25 times 5 is 125. Times w to the 6. And 125 is going to be, what is that? 250? Yep, 250. So 250 w to the 6th power. So this one was interesting because we had to use 2 rules of exponents. All right, let's take a look at number 8. So we have 18 m squared times m divided by 3 to the 3rd power. Ooh, more going on. Let's see. I always like to get rid of the parentheses first if I can. So can I simplify anything inside the parentheses? M divided by 3? No, I can't simplify it. So let's look at our rules of exponents. What can we do with those parentheses? Well, let's see. The m over 3 to a power looks a lot like number 4. So let's go ahead and use that rule. So we're going to give the 3 to each of those variables or numbers inside the parentheses. So 18 times m squared times m to the third power over 3. And now remember, these numbers can all be we can all write them as over 1. So now we have multiplication of fractions. I'll go ahead and multiply across, which means I have 18 times m squared times m cubed all over 1 times 1 times 3. 3. Can I simplify further? Well, I have these two m's to the third power here, and that rings a bell. Let's take a look at any of our rules. The m to the squared times m cubed looks an awful lot like number 1. So what do? We keep the base and add the exponents. So that's going to equal 18 times m, 2 plus 3, that's 5, all over 3. And then can we simplify any further? Well, let's see, 3 and 18. Yeah, 3 can go into itself once, and 3 can go into 18 6 times. So my final answer is 6m to the 5th divided by 1, which we can actually simplify, remember, into 6m to the 5th. Okay, so we have 2 more problems to go, and then we're done with this class activity and the video. All right, so number 9. Go ahead and try number 9 by yourself when I write it down, and then check back with the video after you've paused it. All right, so let's take a look at this. Once again, we have the parentheses, and as I always say, work with the parentheses first if you can. So let's see, is there multiplication going on in the parentheses? Yes, that's multiplication, so the rule I can use is number 3. This is going to be 5a times 4 squared times a to the third raised to the second power. And we still have parentheses, so what rule can I use to get rid of those? That rule looks like number 5. I have a power raised to another power, so I'm going to multiply them together. So I'll multiply the 3 times the 2. This is going to be 5a times 4 squared times a to the 6th power. Let's see, can I simplify? Well, I know what 4 squared is. That's 16, so I'll go ahead and simplify that. 5 times a times 16 times a to the 6th. Now let's see, do I have any bases that are the same that I can combine? There are no other 5s, and there are no other 16s, but there are 2 a's here. So I'm going to combine them using that first rule of exponents, where you keep the base and you add the exponents. So that's going to be, let me rewrite this, 5 times 16 times keep the base and add the exponents. That was a 1, plus, and that was a 6. So this is going to be 5 times 16, which is, I believe, 80. Let me check that on my calculator. It is indeed 80. 80 times a to the 1 plus 6, 7 power. Are there any other rules of exponents I can use? Well, I don't see any bases that are the same, I don't see any parentheses, and I don't see any division. And all our numbers are multiplied together, so that looks good. That's simplified. Our last problem, number 10. 2p cubed x to the 5th divided by p to the 8th times x squared. Ooh, this one's got division now. So let's see. First, before I do the division, I'd like to see if I can simplify anything on the top or the bottom. Are any of these like terms? Do any of them have the same base? That's a 2, a p, and an x. And there are no parentheses. So I can't actually do anything on the top. Can I do anything on the bottom? Well, the bases are also not the same either, so I can't do anything on the top or the bottom. So now let's look at the whole fraction. Do I have any rule that uses a fraction or like a division? This rule and this rule. But we don't have any parentheses on the outside, so we're probably not going to use number 4. So let's look at number 2. It says if you have the same base being divided by itself, then you can subtract the exponents. So is that happening in this problem? It is. We have a p and a p and an x and an x. So let me split this up so we can look at it better. This is going to be 2 over 1 times p over 3 divided by p to the 8th times x to the 5th all over x squared. Yep, so we can break this up because remember, if I tried to multiply this back together, I would get the same answer. Let's check. 2 times p cubed times x to the 5th. That would be the top. And look at the bottom. 1 times p to the 8th times x squared. That would be the denominator. So it's perfectly fine to split up our fraction this way. Plus, it helps us get to see how to use this rule better. So 2 to the 1, that's still going to be 2 over 1 times. Now let's see, when we have the same base and they're being divided, we're going to use subtraction. So that's going to be p, and remember, the top exponent is always going to stay first, p to the 3rd power minus the bottom exponent, which is 8. And that's being multiplied to, same thing's going to happen here. Keep the base and subtract their exponents. Alrighty, simplifying this, 2 over 1 times p to the 3 minus 8 is negative 5. Ooh, a negative, interesting. And then x to the 3rd power. Okay, are there any other rules of exponents we can use here? Well, okay, so one thing to mention